We are down to the last section of the term and last section of our time together of the semester. You're going to be needing your calculator today, and we're going to be working with this formula, A equals A sub 0 E raised to the RT power. A is the end amount, A sub 0 is your starting amount, E is the number E, so we're going to be using our calculator for that. R is the rate, percent, which we're going to have to change into a decimal, so decimal form. And then T is time, and time can be in years, minutes, depending on the situation. And when I talk about the end amount and start amount, again, it can be anything. We'll be population, we'll be talking about money, all of those kinds of things. Before we get too far into it, I do want you to take out your formula sheet. The formula was written down wrong. It was A sub 0 equals A, and the correct formula is A equals A sub 0. So please change that on your formula sheet. I'll remind you again when we meet in class as well. But this is how it works. We are going to be setting up the formula and solving for different parts. Every problem is going to have a little bit of different number maybe that we're going to be looking for. Some of them are just going to require a straight punch in your calculator to get your answers. Others are going to require some manipulating or moving around of the problem in order to figure out what to do. So for a period of time, an island's population grows at a rate proportional to its population. That just tells me that I'm using this form, that I'm using exponential growth, a rate proportional to its population. If the growth rate is 5.9% per year and the current population is 1,085, what will the population be in 10.9 years? So I'm going to be given the rate, which is 0.059. I do the decimal form of that. The time that I'm looking at is 10.9. I'm given the starting population. We're looking at currently where we are, 1,085. And what I'm looking for is what the end amount is going to be. So I have everything that I need to set up this problem. It is A equals A sub 0 times E raised to the RT. On my calculator, I've talked about this before, my E is found above the natural log. So when I plug this in, I always get a glare here, sorry about that. When I plug this in, let's see if I can get it above so you can see my finger moving. I think you can. Okay, you can see that flashing. This is 1,085 times second ln, that'll bring the E up, and then I do 0.059 times 10.9, end that parenthesis, hit equals, and so my end population will be 2,064. We're talking people, population, so 2,064 people will be the end population and that on that particular island. If it's population or money or organisms, we're going to be doing, you know, like one of the problems, E. coli, they bring up. The formula doesn't change. It's all exponential growth, but the one thing that I do have to be careful of or watchful for is decay, because when we have decay, if they give me a decay rate, and a decay rate would be negative, even though they wouldn't tell me that it's decreasing at a rate of, they wouldn't make it a negative R. I need to make sure that I make it a negative R when I plug it in. So a savings account balance is compounded continuously. That's the same as rate proportional, compounded continuously. If the interest rate is 3.4% per year and the current balance is $1,347, what will the balance be in 10.8 years? Again, this is a very similar problem, just with money instead of population. I have a rate, 0.034, put it in decimal form. I have a time, I'm looking for 10.8 years down the road. I have a starting balance, 1,000 $347. And what I need to find is where it's going to be. Oops, that should be, I don't know why I wrote that like that. Sometimes I do silly things. So a sub 0, where I am, is 1,347. Again, it's the same thing. A is equal to 1,347 e raised to the 0.034 times 10.8. Plug it in. And I got 1,492. Now this one, 1,492, I'm going to put 77 cents on the end because this one I'm talking about money. So how you answer your question can change. What we use to get the answer doesn't change. How we answer can change according to the situation. So people or population, you can't have a percentage of a population. Money, we go 2 numbers after the decimal. So just keep those kinds of things in mind when you're working through. Savings account balance is compounded continuously if the interest rate is 3.7 per year, and how many years will it take to double the balance? Well, this one's a little bit different because I have the rate, my R is 0.037. The time is what I'm looking for. But when it comes to the amount, they don't even say how much I have. But what I do know is that whatever I start with, I want to end with twice that. So I should write that like this, my end amount needs to be twice my starting amount. So when I set up my equation, if it's 3 times, it would be 3 times that starting amount. So when I set up my equation, I get 2a sub 0 equals a sub 0 e raised to the 0.037 t. It looks like I've got way too many variables going on in here, but remember, e is a number, and the a sub 0, I can divide that out. In fact, when I set up these problems in the future, I'm not even going to write this part of it. I'm going to jump down to this next line. Oops. E to the 0.037 t. All right, now this is where I have to use the natural log, because what I need to do is drop this power down. And so remember how this works. I'm just converting into log form. The log base e of 2 is 0.037 t. The log base e of 2 is 0.037 t. That's just that exponential and log conversion. Well, we don't do log base e, we do ln 2 is 0.037 t. Now I can figure this out. ln 2 divided by 0.037 is going to be t, just doing some algebra. And so I'll take my calculator, ln 2, finish my parenthesis, divided by 0.037, and we'll come up with, it looks like 18.7 years. So my t is 18.7 years to double. That would be my final answer. So I'm going to have to resort to converting into log form. Again, usually I jump from here to here. I just take the natural log of both sides, essentially is what I'm doing, or I convert it into that form. Log base e of 2 is the power, and that's how we solve those. So during the exponential phase, E. coli bacteria culture increase in number at a rate proportional to the current population. The growth rate is 1.9 per minute. In how many minutes will the population triple? So now I'm going on to triple. So my R is 0.019. The time is how many minutes I'm looking at. This one was years. How many years will it take? How many minutes I'm looking for? That's my time. And I don't know the a sub 0. I do know that the amount is 3 times the a sub 0 that I want at the end. Again, the a sub 0 is going to cancel out because this is triple. I'm just going to write it right away like this. 3 is e to the 0.019 t. And again, I need to write this in exponential form so I can solve for that power. I'm going to use the natural log. So I just do ln3 equals 0.019 t. Again, that's a log base e of 3. But I write that as ln, and then I can solve for my t. So I do ln3, close my parenthesis, divided by 0.019, and it's going to triple in 57.8 minutes. All right, so on the back side, we've just gotten into the how we use the ln here, how we set it up, how we make sure we answer our questions depending on the scenario. Now we're going to get into some that might have some decay. Our first one is a decay problem. When we talk about a decay rate, we have to keep in mind that a decay is a negative. So this radioactive isotope carbon-14 decays at a rate proportional to the amount. Again, this statement and the growth rate, all of those things are continuous, compounding continuous. All of those are saying use this formula, A equals A sub 0 ERT. That's all that's telling me. And so my rate here is negative 0.121 per 1,000 years. In how many years will the mass, now I have to remember that, per 1,000 years, in how many years will the mass be reduced to 1/5 of its initial mass? So again, the time is what I don't know. And the amount that I'm starting with, I don't know. I do know my end amount is going to be 1/5 the starting amount. So when I set this up, I'll just do 1/5 equals e to the negative 1.121 t. Again, another very similar problem. So to drop that power, it's ln 1/5 equals negative 0.121 t, and ln 1/5 divided by negative 0.121 will give me my t. Remember, t is per 1,000 years. So when I do this ln 1/5, you can use a fraction key if you want to, just end it in parentheses when you're done, divided by negative 0.121, and we end up here with 13.3 thousand years. Watch out for, again, how you label your answers depending on the scenario. Going on with another decay, radioactive isotope curium-246 decays at a rate proportional to the amount present. The decay is 14.65 per 1,000 years. In how many years will the mass reduce to 1/2? So we can start, I think you're getting the gist of it. We can start setting this up. I'm going to have half the amount left, e raised to the negative 0.1465 t. ln 1/2 will be negative 0.1465 t. When I plug that in the calculator again, ln 1/2 divided by negative 0.1465 looks like 4.7 thousand years. 4.7 thousand years again. Down to our last two, and sometimes we're going to have to do two problems to work our way through. In this one, they're telling me that it doubles in this amount of time. I need to figure out how long it's going to quintuple. Quintuple, remember, is 5 times the amount. So I have to set this up twice. I don't have a rate. I need to figure it out. So a savings account balance is compounded continuously. Again, that tells me I'm using that formula. If the balance doubles in 20.4 years. So this is my first part of my problem. If the balance doubles, so that means I'm going to end up with 2 times what I started with in some r times 20.4 years. That's how long it's going to take to double. Well, I need this r in order to find out how many years it's going to take to quintuple. So watch problems like that where there's sort of a double setup. I need to find the r in order to find the quintuple part of it. So I get ln2 equals 20.4 r basically, and ln2 over 20.4 is my rate. Now I'm going to leave it like that. I'm not going to plug that in the calculator. I'm not going to round it. This is just going to transfer into my r in my next problem. And how many years will the valence quintuple? So I want to get 5 times the amount I start with when I'm done. E to the ln2 over 20.4 t. I know that's kind of ugly and a little bit weird, but I'm just going to keep that in there anyways, because if I start rounding too much, I start losing accuracy, and I don't want to do that. But how I continue from here is going to be the same. The natural log of 5 will drop down or get rid of that e, ln2 over 20.4 times t. So I'm going to divide that out. So it's ln5 divided by ln2 over 20.4. So this whole thing is going to go in parentheses in the bottom, and that will give me my t when I'm done. Okay, so I'm dividing that ln2.20, or divided by 20.4. So this is what it looks like in my calculator again. I do ln5, close that parenthesis, divided by parenthesis ln2 divided by 20.4. So I have that whole thing in the bottom, and it looks like it's going to take 47.4 years. 47.36 something something. It came out to be 367 blah blah blah. So I'd say 47.4 years it will take to quintuple. A lot of times when I do problems like this, I see if that makes sense. Well, if it takes 20.4 years to double, 47.4 years to be 5 times the amount makes a lot of sense to me. We have one more that's like that. For a period of time, an island's population grows at a rate proportional to the population. If the population quadruples in 32.2 years, in how many years will the population triple? And so again, we're going to take a look, we're going to set it up, find our rate, because we need to find the rate. We've got this part first. It quadruples. I get 4 times the amount in 32.2 years. So ln4 will be 32.2 times r, or ln over 4, or ln4 over 32.2 will be my rate. Again, I don't like to round, I like to keep it there. This is what I'm going to plug in for my r when I set up the next part. So in how many years will it take for the population to triple? I know it's going to be less than 32.2 years because it quadrupled in that time, so I just sort of think of that kind of stuff when I'm setting it up, what my answer should look like, so I know if I'm reasonable or not. So I would do 3 equals e raised to the ln4 over 32.2 times t. So ln3 equals ln4 over 32.2 times t. So ln3 divided by ln4 over 32.2. Oops, get that so you can see it. Again, that whole bottom has to go in parentheses, will be my time. So ln3, end that parenthesis, divided by, open parenthesis, then I do ln4 and that parenthesis divided by 32.2, and then end the final parenthesis on that problem equals 25.5. So I would say 25.5 years. Did it triple in less time than it took to quadruple? Yep, so that seems like a reasonable answer. So again, your homework is to do the 13.3 evens or odds, and There'll be different variations of these types of problems. As always, come in with questions when you come to class the next day. And then we'll be working on the review for your final.